I'm here with Brian Ritter, who is the Principia College solar car driver, and Kenneth Stack, who is the lead aerodynamics man. Can you guys tell us a little bit about the solar car project?
Sure. So Principia Solar Car started, I believe, officially in 1993, under David Cornell. He was a physics professor. And they started out as just kind of an electric car kind of project. They built an electric bike with batteries, drove it from this old science center up to the gatehouse, and had to pull the leads off the battery because they had no brakes and no way to stop it. So that was like the first kind of inception of the project. And then in 95 they built their first car, which didn't qualify for the race, and they kind of went along as an exhibition team. So that was kind of where we started how many years ago, over 20 years ago now. So yeah.
And it's progressed over the years, right? You've had different models as time's passed?
Yeah.
That's right. We're on our 9th car right now. So over time, the rules have changed, and so our cars have changed with them, as well as improving the materials and the methods that we use to build and design our cars.
So can you guys tell me a little bit about what your individual roles are on the team?
Sure, I guess I'll start.
Yeah.
So initially I was just kind of like pit crew and did whatever I was told because I had absolutely no idea what I was doing. And I've kind of grown into the electrical lead. So most of the electronics on the car, the batteries, battery protection, some stuff with the motor and the array, telemetry data are the main things that I work on. And then I was a backup driver my sophomore year, and then I've become the lead driver for the races as well.
I started off the same way as Brian, just doing whatever was needed to help out. And then I found out that we were going to be designing and building a new car. So I was really interested in being part of the design process. So I learned the software. I spent a lot of time on the tutorials involved with that, and I started figuring out how we would design a new car, because we didn't have anyone on the team with experience in this program. So just because I was part of that process, I ended up designing the full shape of the car, the outside of the car. And also the software allows us to analyze aerodynamics over the car, how air would flow over surfaces. So I got to play with that some and figure out how to optimize our car. That's the main role that I've been playing. But I've also seated tires, putting the tires onto the rims, and other small roles that I've gotten good at.
Brian, can you say why you're the driver? What specific qualifications do you have that make you good for that role?
Yeah, there's a lot of factors that go into it. First, since we're such a small team, we have to have people that fit in the car. You can't really change how how the car is designed and how the frame fits. So there's certain people, anybody taller than me pretty much can't fit into the car because you have to have a certain amount of clearance between your head and the bars that go around it. So we've tried to fit some people who are 6 feet tall, even 5'11"-ish, and it's pretty tight. So that right there wouldn't pass the regulations. The other part, I guess, comes down to we do put a few people into the car and have them test drive it. Part of it's efficiency, just the ability to listen and follow directions, keep calm when things are going poorly. A lot of different factors, and we do training for drivers and test driving, and then usually narrow it down to 2 or 3 people with one person who's kind of maybe the most efficient or the most experienced in my case. That's basically how it came about. With bigger teams, they actually do send some of their candidates to like professional driving schools. I know University of Michigan does that, and then the drivers have to be exactly the same size, like 5'8", 150-ish pounds or something like that. So they're all very similar in size, and they have a lot of training. So ours is less formal than that.
What are the conditions like at the helm of the new solar car? Is it hot in there? How does it go?
Oh, yes, it is. And our most recent car that I've driven was Raw 7S. The entire black body. It's the one that looks like a manta ray or the Batmobile, some people think. But yeah, when it's sunny out, it can get up to about 110 in there. And I was in the car for several hours with that. We do have a little airflow. We installed a fan partway through the race to kind of blow on the driver's face. And we have a Camelback that has water in it for the driver. So it's not terribly uncomfortable, and honestly, you have to focus so hard that it kind of, that stuff falls by the wayside when you're focusing on driving, but certainly not as comfortable. And it handles a lot differently with no power steering. It's all very, very minimal changes affect it pretty significantly.
Something you might both be able to talk about. Obviously, people don't know a whole lot about the solar car. How would you guys say it compares to a normal car, say on the road? What's like the top speed? How does it handle things like that?
Around 60 or 70. We've had cars go up as fast as 85 or 90 before on speed close course races. Handling is I think the biggest one, and you can really feel the wind because the car is so light. I mean, I've driven a Prius, and on River Road the wind will push you around a little bit, but when you're in those little cars and you'll feel a semi go by or even a normal car passing, and it's not, I've never felt unsafe on the highways, but you definitely you feel it, and you notice that kind of thing more. It's really bumpy. Every bump on the road where like the cement was put together, the different chunks, you'll feel all of that. And then having three wheels definitely makes the turns feel a little different. It kind of, not really slides, but there's definitely some, the way that it turns is different.
Yeah, I could add a little bit onto that just from a physical point of view. The car isn't as durable and as well tested as commercial cars, so we have to be careful around it when we're handling it. Things can break more frequently than you'd expect on a normal car, so a lot of repairs go into it during races especially, and just overall being cautious and careful, especially around the solar cells and other delicate parts of the car.
It is kind of amazing when I think about it. When I get into a normal car, they have all those crash test ratings, like 5-star ratings and all of that. And then you think about our team of 20-odd liberal arts students making a vehicle that you're driving on highways is going 60 miles an hour. Sometimes I do think about it, and I do feel safe, and we do have lots of precautions that we take to make sure people are safe because it's a priority for many teams. But I think it's pretty cool that we can make something that drives alongside Toyota cars and Ford and Chevrolet. And
so the electronics necessary to make a car like this, obviously both kind of varied and pretty extensive. What is the cost that goes into something like this, say a new car?
We spend, $160,000-ish each build cycle.
Yeah, we usually say like close to 200,000
Around
for a build cycle every 2 years about.
And that includes races. So going to Australia is about $50,000 to ship the car and just get students there, travel costs, food, things like that, lodging. So around $150,000 for the car. Batteries and the array are probably the two biggest, and the motor and motor controller can be as much as $10,000 or so for each of those things or higher. So there are some expensive electronics are the main costs.
So why rebuild a car as opposed to just making adaptation?
Well, the rules have changed significantly for these upcoming races. The seating position is different. We have to have 4 instead of 3 wheels for the upcoming races. And the way our car is made out of carbon fiber composites, it's difficult to nicely reconfigure wheels, and as well as the whole chassis needs to be rebuilt for these new rules. That's the main reason, is the rules, and we can also improve on things that we've learned from in the past.
It also comes down to just durability as well. I mean, we've driven Raw 7S, our most recent car, in Australia for a couple thousand, and across the U.S. for another couple thousand, and that frame was in Raw 7, which was the previous car, but the same body, and that had another maybe 3,000 to 5,000 miles on it. And normal cars wear out much slower, but they do, have a life, a shelf life, not a shelf life, a amount of time on the road that they can last, and ours is just a lot less than that. So
how do you remain competitive with programs that have a much larger budget? You mentioned Michigan's got a massive program, right?
Mm-hmm. Yeah, I think part of it just comes down to improving and making sure that every subsequent team knows why we did the things we did and how to improve on it. And then having a few key people who dedicate a lot of their time to doing stuff like Ken did this past summer, and throughout being on Solar Car with coming up with the body design and everything like that, has put in countless hours, and having people that are dedicated and really want to do stuff on the project and can learn from all of the stuff that we've learned over previous cars.
Something else that I've noticed, even though we don't have engineers and we don't have the engineering skill set that other schools do, we do everything else really well. The care that we put into making parts and our car, as well as just taking our time on the tasks that we do and making sure that we cover a wide variety of things that are important for the race, not just the car, but logistics, as well as being able to have the support from donors and all the other things that go into the race. Those we do well. compared to some of the top engineering teams.
So obviously you guys really enjoy, being on the solar car team. You've dedicated a lot of your time to it. Do you expect this to have kind of a tangible payout in the real world? Are you looking to go in and pursue something like this after graduation?
Personally, I'm planning on studying electrical engineering, which I decided to do based on my work with the electrical systems on the car. So it's something that I thought I wanted to do, but wasn't sure when I decided to come to Prin, and it's given me that drive. I don't know if I'll be doing stuff with solar power or with cars, but I think that the experience has definitely helped me with what I want to do in life.
This past spring, Garrett, myself, John Brewer, and some other faculty went to Texas for a Siemens conference. Now, Siemens is the sponsor who provides us with the software NX that we use to do all of our modeling and analysis of our car. They invited us, our school, out of all the other schools that they help, and we set up a booth there with our car to talk about how we use their software and how it's benefited us. We also gave a presentation to about 1,000 people about our car, and right after the presentation, the president of Siemens came up and talked to us to ask if we were interested in an internship. And Garrett did that internship with Siemens this past summer. So it definitely does have tangible effects on our careers, as well as meeting lots of other people in interesting fields during that conference. We got business cards. Another student is pursuing an internship with Apple that was made through that connection.
So what happens with a solar car once you retire it? Is it a joyride mobile or what?
Sometimes it gets cannibalized for parts. We've taken things out of, I know the original cars back when our budget was small, although we don't necessarily have a huge budget now, but back when it was, just starting, they would take things out, anything that they could use, and I think they've ended up getting rid of some of those original ones because they were so destroyed in the process of taking everything useful. We sold the body of one car to a father-son, and they have been using it, I think, in the salt flats as one of those high-speed, drag racer type things. We have a couple of our cars, more recent ones, just in storage that we're planning on pulling out for our alumni reunion this coming summer. So they're kind of all over the place. I think we sold the lower body of one car to a school in Egypt right before the revolution happened, and didn't get any money from them. But at least everybody was safe and went over there. So I guess it worked out. But yeah, we have them in storage, and we actually did look at them when we've been designing our new car just to get some ideas on how to do some of the suspension and the mechanics.
Are you guys competing anymore? You're both graduating this spring.
Yeah.
So are you still going to be competing this spring?
This coming summer there's a race. I would love to be able to go on the race this summer in July, but I still don't know. I don't know about you, Ken.
I'm planning on going on the race this summer. After that, I'll still be here next school year, working as a post-grad teaching intern for the physics department, mainly so that I can continue working with solar car because I love it so much.
Great. Well, thank you both so much for your time.